facility.
Thanks so much.
Yeah. In here is where the crazy happens, and our newest systems. Your flight stack is still technically in R&D, and I want you to meet the brains of the operation. This is Tyler.
Hey, Chad.
Tyler, nice to meet you.
Nice to meet you.
This is Arnold, one of my project managers.
Nice to meet you.
I like your skunkworks sign up top.
Oh yes, we're the do anything, think outside the box, custom, crazy. We do it here. Your product over here.
Great.
We're just in the midst of packaging it up for you.
Lovely. How's it been going putting this one together?
Real good, real good. Everything went pretty smooth. Your product is cut over in our Plant 6, powder coated, and we actually bring it here, do all the custom fab, assemble it, weld it.
So I have a question. Since I'm never going to see the structure anyway, this steel, why do you paint it?
It just gives it that little bit of extra protection. It is a pickled in oil steel. It will not rust. But just to give it that extra look and extra protection, we'll powder coat it. When you unpack everything, everything will be labeled here for you, and you'll receive these prints. And on the prints, you'll see everything will have a label, and you'll be able to match the same label up with what you have, and you'll know where it goes in your assembly.
So this over here, this is the first floor up to the platform, right? So that's the bottom of the stair, that's the platform level, right?
That's correct, yeah. And you can actually see how it goes. The platform goes on up, mounts into the header plate. So yeah, you can see here we actually have your first and your second use labeled for your upper, and you have all of everything. And B is off for the bottom section.
And why do you have these big knockouts in the platform?
So a lot of these are for weight savings, easier to handle, a place to grab a hold of when you're manhandling it. It reduces your weight when you're installing it, and it gives you room on your side where we run all the electrical.
Wow.
So if we do have any issues later on, there are access points to get in to service it.
That's great. And these pieces are all made in smaller increments and welded together? Is that how this works?
This actually is broken down into 2 pieces, and so a standard sheet that fits on the laser is 10 feet long. And so depending on the length, they could potentially be 1 piece or smaller. We actually seam it, and you can't even see where we seam it. So it's...
I'm cheating, I can see the seam right there.
There you go. So we actually will, where it's cut, it actually gets beveled on both sides, and we'll fill it in and then grind it. We'll leave just a little bit there.
Yeah.
That way it gives it just...
And it's like almost like a shiplap connection that you make there.
Yeah, it's like a puzzle piece. So when it goes together, you have strength in both directions, and you can't mess up how it goes together.
Right. And that vertical leg's giving you a little bit of extra shear performance on that weld.
Yep.
We have done it every wrong way there is to do it. We've done it out of LVLs, we've done it out of plywood, we have done it out of solid wood, we've done it out of a whole bunch of little pieces of sheet metal, we've done it with putting a steel tube in there, and we're really finally settled in. This is probably system 4-ish that we've done in this method, and now we're just turning the knobs really, really finely. And Tyler's team has really leaned into that.
We use PlanGrid as a program that we use where we load all of our plans and shop drawings and everything onto tablets so that multiple supervisors can at the same time have them. Nice. And they can actually do things like mark a part as installed and synchronize through the whole company that we know we got that part and it's in. These diagrams are great to work off, and you can really see a visual reference. Like, it doesn't take much to realize that this is either B42 or B5. Having a different label for B42 and B5 is a step up from some other people who would say that's the same part but just reversed, right? You know, not make the guys have to think which is the left piece, which is the right piece. In both sequences where we've done the upper one first and then come down to the lower one, and then we've also done the lower one to the upper. My thought in planning this was that we were going to put the lower stringer in, for the lower set in first, because we have the diagonal cross brace that's going to get welded onto the house's structure. So our plan was to actually use the platform, the temporary platform of the lower stair to post and hold the upper stairs platform as we work, so that we've got that in place.
If I can, I do like to do the bottom one first, We have dimensions where the header goes, where the foot goes, and you can assemble this, and all the wood parts work as construction treads. So you can work off it and work ladders on it, scaffolding, whatever needed, to assemble your upper one.
Yeah.
And what's nice is you don't have to worry about scratching your final wood.
Because of the sequence in these projects, we're building a house like this in typically, 6 to 9 months. This one's going a little longer due to some custom finishes, about a 12-month job. But, we don't have a lot of other spaces for staircases except where the staircase goes. So typically we build a wood duplicate staircase of this when the framing goes up, because we need access that's heavy duty.
Yeah.
And now that you guys have shifted gears to do that way, we're going to switch to ordering our stairs when we order the steel superstructure for the houses, so that the next thing we do after we're putting the sheathing on the house is install the Viewrail structures and get the temp treads in and just live with your staircase for the entire time. And it'd be a much better temporary stair, and it won't be temporary, it's the permanent stair, and we can just continue everything around it.
We have the option of cutting all the glass panels out of wood, and two things that does is it gives you that temporary railing, and it verifies that all the holes in the glass match up to what they're supposed to be.
I've never heard of that option. That's a great option.
We'll go through, you have holes in your wood, which goes through these larger holes, and those will bolt, and then you have the smaller holes that you'll be able to run screws through into your wood.
So these are lag bolts for these? Or they're actually internally threaded?
These are internally threaded bolts.
So you've got like T-nuts or something inside the wood tread?
Some of them are just...
No, but that's a good idea.
Yes.
I didn't even think about T-nuts until just now.
Okay, there you go.
Good.
But so what do you do? We're sinking a lag bolt into the side of the wood tread?
You can drive your bolt right through into it, and then when you tighten everything up, it draws it off.
We're bolting using a standard hex bolt from the inside of our wood box. We're going through the wood box, we're going through the steel, and then on the outside of that, we're going to put a nut on there to cap that off. But later on down the road, when you get your glass panels in, we're going to use that same bolt to attach the glass panel with some additional hardware, similar to what you guys have used with Videra.
Right, I think I saw that before, and you actually have a wood spacer that goes in there too, right?
Yeah, so we use that wood spacer to step us away from that steel, make sure we don't have any chance of glass contacting steel. We know those two materials never mix. It also spaces us away from that nut. But it also, for you and for me both, is a significant reduction in the number of little fasteners that you have to be working with on site.
Right, it's like we're using that triple word score thing a lot, but it makes sense here, right? You put the one in to hold the finish, the rough tread, and that's, that one hole is doing everything for you.
Here you can see that spacer that JJ was just talking about. Everything is CNC'd, so it's cut perfect. So we know it'll fit right on there.
And that's a wood spacer that just looks just like this. It's like basically, so you understand this, basically another piece that looks just like this, made out of plywood, right? It's a little unique. Viewrail using wood for that. Typically, you're used to seeing nylon or elastomer or something like that in the glass industry. But you guys being experts in wood, there's no reason wood's a great material for that as well. I see that these are some wide open holes here. What's the top layer on here? It's a...
This will be a plywood on top.
That's like a 3/4 plywood.
3/4.
So we still want to, Arnold, you want to make sure, when you post above, to hit these ribs and not just be bearing down on the 3/4.
When we're going down the...
When we put the temporary post in, we're putting a temporary post in to support the 3rd floor platform while the steel guys are working to weld that cross brace in. So while that's going, the tribal logic would be to put a post here and a post here. But you're going to be right in the middle between the plywood, in the softest part of the plywood, so you're not going to want to be putting a lot of stair load up on that. So we're going to make sure that when we land those temporary posts, we either do them on the way outside, so you're right on the steel, or you do them in the center rib or something like that.
For round one here, we just got some labels, put them on, and so you'll see what each part is. Those are your 2 columns right there. This one, they wanted to make sure they put it in an area where you could easily see it, the label. Since everything's going to get covered over, if something would be showing on this, we'd always want to make sure it's going on the side that's not showing.
Right.
But since everything's being buried here, we wanted to put it on the side that was easily visible when you grabbed it.
Got it.
And this is countersunk here, so you'll be able to bolt on so that will have an internal welded plate, so that'll just get bolted on. So over here we can look at your wood parts. But again, What's nice about this is not just parts that were cut out, you know, on a chop saw. Everything is CNC'd. Everything is, you know, everything's perfectly square. You know, everything's going to, you know, be located where it needs to be.
So even this this 2x-dimensional lumber, you cut that on
just the
apply.
3/4. Yep.
Yeah. But I love, even still, you know, you give us an eased edge. It reminds me of, I was in the film industry for a period of time. I went to film school, and these look like apple boxes. I don't know if you know.
It sure does.
We really try to go into the details. That, I mean, that's trying to set us apart. I mean, it's the little things that make all the difference.
Yeah.
We built several of these boxes with chop saws, and we have nice chop saws, we have nice equipment, but we just found the precision wasn't there.
Yeah.
And so when we got to your round, we knew that we had to cut all these parts on CNC, because these just look like apple boxes, but these are incredibly precise boxes. And that's what enables us to marry steel and wood together, and all of the bolt holes line up, everything come together, and you be able to have the strength and the fit and the finish you're going to need.
So this hole right here, this is what's ultimately going to support glass through here?
So some of these is just to get it mounted up. And so you can run, you know, run a screw through and get it mounted, just to help with ease of installation.
But when the glass is actually bolting through, what's the nut, if you will, on the back, or what's the media that's holding the bolt that's supporting all that glass?
So we have in the steel, we have a welded in weld nut in the steel that's actually taking the load of the glass.
Oh, okay.
So these are just to get the tread in the steel, but the steel's doing all the work.
Got it. But all through that common hole, nonetheless.
Yes.
Wow.
Yep.
Really a lot of thought goes into that. These treads are I call them the origami style, you know, where this is going to fold around. Is this critical also for that fit up, or is this just really just for safety purposes?
A big part of the story is we're going to have to bring pieces of wood together here.
Yeah.
And as we're bringing pieces of wood together here, we're going to have some adhesive and some other pieces on the decorative.
Yeah.
And it's nice to not have a sharp edge that could have any goobies or any splinters, and so that we're able to get a really crisp 90 and as we're putting the wood. But it also serves that other purpose of during construction we've eased an edge. Every detail, I would love this to believe that we are so smart that every detail that you see here is because we thought of it ahead of time. Every detail you see here is a result of a mistake.
Yeah.
Every time you see something like that, it's because we did it wrong once.
Yeah.
But we have the privilege of being able to do so many of these stairs that we're able to iterate and get it to as near perfection as what is possible. And Flight Stack is pretty much there, and you're going to experience that in your install.
And I think, you know, when I'm explaining to clients like why am I buying a staircase from Indiana instead of, you know, there's plenty of people who can manufacture a staircase in New York, obviously. And what I always say is exactly what you just said, which is that you guys are invested not only in the project that we're creating, but also the outcome of that product. And like, if that project doesn't work out perfectly, you want to know about it, and you guys are going to usually stand up to the table and fix that problem for us, and the next one for me will be good, but for that customer who this is their house, they can stand behind the fact that you guys see a lot of value in your mistakes, which is a really big deal. We see value in our mistakes as well.
So you didn't pay $1 million for Flight Stack.
Yeah.
But I've put $1 million into getting it to where it is today because I believe in it, and I see where it's going to go. And I know that we have to make that kind of investment in getting it perfect so that you and Arnold are able to execute when it comes out here, comes out to your job site. You're limited on the time and the amount of daylight that you have to be able to work on a house, and you have to be very productive. So we're doing everything we can to make you productive and efficient.
The last time I was here, I was joking about how the wall was attached. You know, it's like, you know, because one of the things I think, you know, people don't realize about staircases that's really important is the elasticity of them, because people don't like walking on a stair that bounces.
You're right.
Know? And this doesn't have the glass on, and it's got basically no bounce at all. And I know once you put that rigid piece of glass on there, that's going to tie it together even more so.
The glass is amazing in the amount of structural strength it gives it.
Yeah.
Chad, they're going to leave us off the leash here for a little bit, and we're going to run off script, and I just want to show you some of what we're doing in R&D, because I know you've got some new projects coming up. So this is one of the first ones. This is cantilever, and we dove in to try to solve a lot of the problems in the industry of cantilever. One of them is, what happens if house is already framed, if somebody wants to switch to it, or if it's a remodel situation. And so we have cantilever built around a wood wall using LVLs. We've got it stamped, we've sent it through the engineering, so it's going to go through all your code approvals. We have these custom brackets. They're adjustable to be able to level. This is a slide-on tread cover that slides over. And so you have to have these treads dead level, and we found some secret sauce on how to do it. So that's one of them. I want to move quickly. Let me show you a couple of others. Chad, the other thing I want to show you is the investment we've made for clients like you who really care about the testing, because you care about it for your clients, municipalities care about it, and just you want to sleep at night. And so this is a calibrated test rig. We bring in a third party to calibrate it. And when we are pursuing a certification stamp, we actually bring a third party who's impartial in to witness it so that they can stamp it. So when you see a product coming from Viewrail, you know it has been very well tested.
So over here, we're looking at like a post that's sitting up over here, and it looks like it has been recently tested for deflection at the intersection between two rails.
You got it.
And looks like it did pretty well. A little bit of deflection, and I'm sure you put, 1,000 pounds on it just to have fun.
So we're always going to test it. We're going to slowly bring it up to the limits. We've got lasers that are measuring the deflection and measuring the poundage, and that's getting stored into a data file so we can go back and recreate and analyze. We have also got video cameras on it. And then you're right, we turn it up to 11 at the end and just, what is it going to take to blow this thing up?
That's always the fun part, right?
Yeah, that's the fun part. It's the guesses that everybody takes. Who's buying lunch is who got the number right on where it's going to break.
What's the most shocking result you've ever got?
How strong glass is.
Yeah.
Like, breaking glass is like really hard. Like, we'll set things up, we'll max out the load cell, and like it didn't break. What are we gonna have to do to break this glass?
I remember one of the first glass railing projects I ever did. The contractor set up for me a 3/8 glass sample and a 1/2 inch sample, and he wanted me to just decide which one I thought looked better on the building. He wasn't charging me a lot of extra money for the upgrade. He said, I just want you to just see both. And I said, I don't really know how to judge it. He goes, just walk up to it and kick it. And, it was a big piece of glass, 42 inches wide, 54 inches tall. And I just walked up to it and just punted it in the center. And it was shocking to think that you could hit it like that.
Yeah.
And what was even more shocking was that even the thin one, it didn't break. No. It just vibrated a little more than the other one. Yeah. And, glass is an amazing material.
This is a lot of fun to talk about because I know where you live and I know how concerned people are about their exteriors. They're concerned about chemicals. They're concerned about the environment. We are too. And we have our own sawmill, our own drying facility, and we've also developed with a partner this thermally modified. So this is actually red oak that has been thermally modified, where we're taking all the sugars and the other things that the bugs are going to like. And this makes it for an incredible exterior product where you don't have to worry about any chemicals in this. And so it's completely safe for humans and for pets and great for the environment.
And we're not cutting down tropical hardwoods.
Exactly. It's an incredible solution. So keep this in mind for one of your next projects.
And this can be installed on the flat, or is this?
It can.
Wow.
It's going to be a decking material. It can be a railing material. It could be a facade. A lot of different uses for this.
Amazing.
So ask me, Len, what's this broken down old thing?
I was just going to say, that what is this old machine? This machine really looks like it has a story.
So this is one of those things I just can't bring myself to get rid of. This is the OG. When we first started making posts, we were on a literal drill press. Now, I wish I still had that drill press, but just after the drill press came this old machine. We called her the fryer. And it was very, very slow and very messy and very manual, but we like to keep it around to remind us of where we came from.
And this is for drilling posts.
Yeah.
So it's just basically a big drill press.
This thing probably drilled, I don't know, 20,000 posts.
And then with this versus what we just saw in the factory, what did you use, a template to lay out the holes, or?
This actually has CNC control.
Oh, it does.
So we're like, I don't know, Microsoft DOS level of loading of programs in here.
Yeah.
Oh, big old RS-232 cables. I mean, it's tech that we learned back in the 80s. That's what we had to use to program this.
Cool. Well, I think you should hold on to it and keep it for the Viewrail Museum.
Yeah, this is the museum piece. So our folks are sick and tired of sanding handrails and wire brushing handrails. And so the team decided we're going to build our own handrail sanding machine.
Okay.
And so this machine, all of the heads move in and out. So as the handrail is passing through there, the heads will come to it and apply the right amount of pressure for doing the sanding. And it's programmable, so when they scan the part at the beginning, the heads will move, and the heads will also know whether to activate these final pieces, which are the nylon brushes, to give it a wire brush texture.
So this is for a wood rail?
This is for a wood handrail.
Yeah.
And I can tell you, a wire brush texture on a wood handrail, it just feels wonderful. It doesn't feel so slick that your hand's going to run down it. Gives you a little bit of coefficient of friction to be able to grab it and feel a little safer.
I just love, I guess somebody here, or many people here, were inspired by the car wash.
Yeah.
Right? Because that's what we got going on here.
It's a car wash for a wood handrail.
But when you say it's scannable, so that means that, like, if you have a handrail that's 1.5 inches wide, then that sets the distance 1.5 inches or whatever it needs to be.
Correct.
And 2.5, they move in and out on their own.
Yeah.
You know, this is really incredible, and it really does deserve to have your, to take the extra time with the pride to put not just Viewrail on the end of it, but also to put a color-changing LED on behind it.
Absolutely. Well, we had a good time here in R&D. Got to see some new products and see your product. What'd you think?
It was great. I mean, I'm so glad we made the trip out, and we feel so lucky and blessed that we were able to synchronize our schedules where you guys could produce stuff and have it ready for us to look at it so that we could get a preview of it before it comes to the field. And I mean, just to see your whole operation from the factory floor through to R&D and the meshing of how the two of them work together, how Tyler's team over here really just crushes it with, being so precise and so deliberate with all of the pieces and the parts and the thought about how it's going to work for us. It was really a pleasure to be able to be in here and an honor to be standing under your Skunk Works sign and getting a behind the scenes tour and seeing all of it is really remarkable.
We love to partner with people like you who have the eye for detail, the passion to really be efficient, to be environmentally responsible along the way, and Viewrail's just really happy to be able to do this.
It's really, you don't always get lucky enough to be working with partners who you're, morally aligned with on top of maybe financially and, basic mission. So to have that moral alignment with you guys is always one of our favorite parts of working together.